Polly the polynomial penguin, talking to you about factoring quadratic trinomials, where a equals 1. Now here's a question. What's a penguin's favorite snack? Ice Krispy treats!
First thing we're going to talk about is a quadratic trinomial. That's an expression of the form ax squared plus bx plus c, where x is a variable and a, b, and c are non-zero constants. The constant a is called the leading coefficient, the b is called the linear coefficient, and c is called the additive constant. Now, I won't make you memorize the linear coefficient and the additive constant. You should know that the leading coefficient is your a value, the number in front. So what I want you to get out of this is that a quadratic trinomial, it's got 3 terms, that's why it's a trinomial, and its highest degree is 2, which is why it's quadratic. I want you to be able to tell me what the a, b, and c values are just by looking at a quadratic trinomial. That's what we're going to learn how to do today. So here, you can see that your a value is 2, your b value is -6, and your c value is 4. We're going to need to know that later on. So we've just seen what a quadratic expression looks like, a quadratic trinomial. Now we're going to learn how to factor those. So the first step when you're factoring a quadratic expression, you're going to look for a GCF, a greatest common factor to take out. If there isn't one or there is one, you take it out, and then you need to go further. Choose a method to factor. Now, we haven't learned any of these yet, but today we're going to get into how you factor using the magic X. So stay tuned on the rest of these. These will be later in the chapter. Now let's review how to look for a GCF or find a GCF, a greatest common factor. So you're going to determine, is there a number and or variable that can be divided into the coefficients of all terms in the trinomial. So here's how this works. What I'm going to do is I'm going to factor each term in this trinomial. So I'm going to factor 3x squared first. 3x squared we break into 3 times x squared. Now 3 is already prime, so that's done. X squared we can break down further into x times x. So this is completely broken down. Now let's break down 6x into its factors. So 6x breaks down into 6 times x, and then 6 we can break further into 3 times 2. Lastly, -9. We can break into its factors. That's just going to be 9 and -1 first. We want to take out that negative, and then we can break 9 into 3 times 3. Perfect. Now, in order to find a GCF, each term must have that factor in common. So let's look. Do each of these terms have a common factor? Yeah, it would be this 3. And I don't think they have anything else in common. So what I'm going to do is take that 3 and put it on the outside of a set of parentheses. Now what goes inside the parentheses? Well, it's whatever's left over from each term. So here, the first term has an x and an x. So if I multiply those together, I get x squared. That's what goes first. Next, what's left over here? 2 times x, that's going to be 2x. So since it's positive, we write x squared plus 2x. And then lastly, we have a 3 and a -1. Those multiply together to make -3. And since it's negative, we write -3 at the end here. That is how you factor out a GCF, a greatest common factor. And you will get to a point where you don't have to do factor trees. You can just look and see, oh yeah, a 3 divides into each of these terms, meaning I can take out a 3, put it on the outside of the set of parentheses, and then just divide each of these terms by 3, and that's what goes in the parentheses. Let's try it again over here. So if I were to break down each term, break down my first term into its factors. 4x cubed breaks into 4 times x cubed. And then 4 we can break further down into 2 times 2. X cubed is a little tricky. You can break it down into x times x right away. Or you can break it into x squared times x to the first, because if you multiply like bases, you add the exponents. So that would give you x to the third. And then x squared you can break down further into x times x. Cool. We've broken that all the way down into its factors. Now let's do -10x squared. So we break apart the -10 and the x squared first. For -10, we want to take out the negative, so it becomes 10 times -1. And then we break down 10 into 5 times 2. Lastly, the x squared over here turns into x times x. And then this 2x at the end, we can break into 2 times x. Perfect. Now, to find a greatest common factor, each term must have it in common. So what do they have in common? They have a 2 in common, and I think all of them have an x also, which means 2 times x, 2x is going to be the greatest common factor. So we're going to put that on the outside of a set of parentheses. Then on the inside, what's left? So from the first term, what's left? 2 times x, that's 2x squared. So that's going to go first in the parentheses. Then what's left in our second term? 5 times -1 times x, that's -5x. So we write -5x in our parentheses. And then lastly, well, there's nothing left over here, right? We took that out for our GCF. So if there's nothing left, you write +1. and you're done. Again, you will get to a point where you don't have to do a factor tree for each one. You can just look up here and see, oh yeah, a 2 divides into each of these, and an x divides into each of these. So I take out a 2x, and then on the inside of the parentheses, I divide each of these by 2x, and whatever's left for each one, that's what goes in here. Now the magic x. In order to solve a magic x, you must find the two numbers whose product is the number on top of the x and whose sum is the number on the bottom of the x. So here you can see the product, we need it to be 15, and the sum, we need it to be 8. So what does that mean? I need to find two numbers that multiply together to make 15 and add together to make 8. So what would those two numbers be? I think that would be 5 and 3. And that's how you solve a magic x. It's kind of fun. It's a little puzzle. Let's try a couple.
Where do penguins like to go swimming? At the South Pole! Example time.
Now example 1 says solve each magic x. So we're looking for two numbers whose product is 28 and whose sum is 11. So two numbers that multiply together to make 28 and add together to make 11. That's going to be 7 and 4. Let's try another one. So here, we're looking for two numbers whose product is 32 and whose sum is negative 12. Interesting. Well, since their sum is negative 12 and their product is positive 32, that means both numbers should probably be negative. So we're looking for negative 8 and negative 4. Let's try it again. Two numbers whose product is 4 and whose sum is 5. Interesting. So two numbers that multiply together to make 4 and add together to make 5. Well, the only two numbers that multiply together to make 4 would be 2 and 2, so that doesn't work, or 4 and 1. Oh, yeah, 4 and 1 would multiply together to make 4 and add together to make 5. Cool.
Why don't you see penguins in Great Britain? Because they're scared of whales! Geography joke, you try!
Okay, for part A, we're looking for two numbers that multiply together to make 9 and add together to make 6. That would have to be 3 and 3. Those two numbers multiply together to make 9 and add together to make 6. Let's try this one. Two numbers that multiply together to make 15 and add together to make negative 8. Well, since the product is positive and the sum is negative, that means these two numbers would both have to be negative, because when you multiply a negative times negative, you get a positive, but when you add them, it'll still be negative. So two numbers that multiply together to make positive 15, add together to make negative 8. The only two numbers I know that multiply together to make 15 would be 5 and 3. So let's do negative 5 and negative 3. Those multiply together to make positive 15, add together to make negative 8. Lastly, we need to figure out two numbers whose product is negative 24 and whose sum is 10. Two numbers that multiply together to make negative 24 and add together to make positive 10. Well, in this instance, we have a negative product and a positive sum. If it's a negative product, that means one number has to be negative, one has to be positive. And since the sum is positive, that means the bigger number has to be positive. So let's think. Two numbers that multiply together to make 24. How about 6 and 4? 6 and 4. Well, 6 has to be positive, and then 4 has to be negative. What's 6 plus negative 4? That's 2. No, that's not 10. Okay, so we can't use those. How about 12 and negative 2? Yeah, those multiply together to make negative 24, and they would add together to make positive 10. Cool, that's how that works. Now let's talk about the bottoms up method of factoring. So here, given y equals ax squared plus bx plus c. So we're given a quadratic trinomial that we're going to factor. What we want to do is first make a magic x. Second, we are going to write the product of a and c at the top of our magic x. So whatever a times c is, that goes at the top of your magic x. B, whatever your b value is, that's going to go in the bottom of your magic x. Then you're going to think about two numbers whose product is a times c and whose sum is b. When you think of those two numbers, you put them here and here. Then you're going to divide each of these numbers by a. Whatever your a value is in your quadratic trinomial, you're going to divide each of those numbers by that. Leave whatever you get as a fraction. And then you're going to write your answer going bottoms up. So here's how this works. In order to factor this, we're going to create two separate sets of parentheses. In the first parentheses, it's going to be ax plus whatever number you have here. In the second set of parentheses, it's going to be ax plus whatever number you have here. That is how you factor using a magic x. Now we're going to do a bunch of examples so you get the hang of it. So first, we're going to factor x squared plus 13x plus 36. So when we're factoring, the first thing you do is look for a GCF. Is there a greatest common factor that you can factor out of each of these? So there isn't a number that you can divide into each of those besides 1. And only these two have an x. This one doesn't have an x. So no, there's no GCF you can factor out. Next, let's figure out what our a, our b, and our c are. So our a is the number in front of x squared. So in this case, that would be this invisible 1. B is going to be whatever's in front of the x. So that's going to be positive 13. And then c is the number tacked on the end. That's going to be 36. Sweet. We are now ready to factor using the magic x. So let's make a magic x. Then a times c goes on top. So what is 1 times 36? That's 36. Your b value goes on the bottom. Boom. You're then going to solve the magic x. So two numbers whose product is 36 and whose sum is 13. Two numbers that multiply together to make 36 and add together to make 13. That's going to be 9 and 4. Now what we can do is divide by our a value. What's our a value? It's 1. Now that we do this, we simplify if we can. 9 divided by 1? No, there's no way to simplify this. It's just 9 and 4, right? But we want to leave it as a fraction, and I'll show you why. We're going to write our answer going bottoms up. So we go 1x plus 9 in the first set of parentheses. In the other set of parentheses, we go 1x plus 4. Now again, if it's 1x, you don't have to write the 1. It's just x. So technically, this is x plus 9 times 1x plus 4, or x plus 4. That's how you factor using a magic x.
What did the cop say to the penguin when he saw him robbing the store? Freeze! You try.
Okay, doing the same thing. Is there a greatest common factor we can take out of each of these? No, there's no number that divides into each of those, and only these two have an x. Okay, so we move to the next step. What's our a? Our a is the number in front of the x squared, that's 1. Our b is the number in front of the x, that is 11, and our c is the number tacked on the end, that's 24. So we start by making a magic x. This is how we're going to factor this. We then multiply a times c, so 1 times 24, that goes on the top of the magic x, and then your b value goes on the bottom. Now we think of two numbers whose product is 24 and whose sum is 11. Two numbers that multiply together to make 24 and add together to make 11. That's going to be 8 and 3. Now that you know that, you can divide both numbers by a, which in this case is 1. And then you can write your answer going bottoms up. It's going to be 1x plus 8 times 1x plus 3, or x plus 8 times x plus 3. Example 3, again, we want to factor. So first thing we're going to do is look for GCF. Is there a greatest common factor? Is there a number that divides into each of these? Yeah, 2 would divide into each of these, right? So what I'm going to do is I'm going to take out a 2, and then in the parentheses, I'm going to write whatever each of these terms is divided by 2. So this divided by 2 is going to be just x squared. This divided by 2 is negative 9. This divided by 2 is 14. Cool. I have factored out the GCF. Now I have this in here, which I can factor using my magic x. So in here, I can now figure out what's my a value. The number in front of x squared, that's going to be this invisible 1. The number in front of x is going to be my b value, that's negative 9. And the number tacked on the end is going to be my c value, 14. So now, to factor this, we're going to use a magic x. So let's go ahead and do that. A times c is going to go on top of my magic x. My b value is going to go on the bottom. I now need to figure out two numbers whose product is 14 and whose sum is negative 9. Well, two numbers that multiply together to make positive 14 and add together to make negative 9 would have to both be negative. So it's going to be negative 7 and negative 2. I then go ahead and divide each of those by my a value. So they're each divided by 1 now. Once you've divided both of your numbers by a, you are then going to try to simplify those. And since they're divided by 1, you can't really simplify those any further. So you just leave it like this and write your answer going bottoms up. So we go 1x minus 7 times 1x minus 2 in the parentheses. And don't forget, at the beginning of the problem, we factored out a 2. So that 2 is going to be in the front of our parentheses like this. And that is how you factor a quadratic trinomial like this.
How do a group of penguins make a decision? Flipper coin! You try.
Okay, so again, we're factoring a quadratic trinomial. So the first thing you want to do is factor out any GCF that you can. Is there a number or variable that divides into each of these three terms? Yeah, you could actually divide a 3 into each of those terms, right? So what we're going to do is put a 3 on the outside of the set of parentheses. And on the inside, we're going to put what we get when we divide each term by 3. So it's going to be 3 and then parentheses. This divided by 3 is x squared. This divided by 3 is 6x. And this divided by 3 is negative 27. Perfect. Now we can factor what's in here using the magic x. So since we factor our GCF, let's get to the magic x. We start by figuring out what is our a value, what's our b value, and what's our c value. We then make our magic x, put a times c on the top of the magic x, put our b value on the bottom of the magic x, and then figure out what two numbers multiply together to make negative 27 and add together to make positive 6. Well, since your product is negative, that means one number has to be negative, one has to be positive. And since your sum is positive, that means the bigger number should be the positive one. So what two numbers multiply together to make negative 27? One has to be negative, one has to be positive, and the bigger one has to be positive. That's positive 9 and negative 3. We then divide each of those by our a value, which in this case is 1, and we simplify that, which since we're dividing by 1 doesn't simplify, you just leave it like this, and write your answer going bottoms up. So it's going to be 1x plus 9 times 1x minus 3. And don't forget, since we factored out a 3 as our GCF in the beginning, that has to go in front of those parentheses. So it's going to be 3 times the quantity x plus 9 times x minus 3. Now our word problem says a rectangular skateboard park has an area of x squared plus 15x plus 54 yards squared. What are the possible dimensions of the park? So step 1 in the word problem, we're not scared, we can do this. Step 2, what are our variables? We're going to define them. So what is the question asking? It's asking what are the dimensions of the park? Well, it's a rectangular skateboard park, right? Which means that the dimensions would be length and width. So we say L equals the length of the park, W equals the width of the park. Sweet. Now, anything else in the problem we need to know? Yeah, the area of the park is actually x squared plus 15x plus 54 yards squared. So since we know the area, we can say A equals the area of the park. And it says it's this right here, right? So that is our area of our park. Now, we're going to write our equation. So how do we write the equation for area of a rectangle? Well, that's going to be A equals length times width. Now what we can do is we can plug in what we know. Do we know the length or the width? No, that's what we're trying to find. Do we know the area? Yeah, we're given the area. It's x squared plus 15x plus 54. So we plug that in for A. Now, can we simplify this? No, not really, but can we factor this? Yeah, notice that length times width are two things multiplied together. So if I were to factor this, that means one of the factors would be the length, one would be the width. So let's use our magic x to factor this. Is there a GCF we can take out first? No. So we just go straight to the magic x. Our a value is going to be 1, our b value is going to be 15, and our c value is going to be 54. So we go a times c goes on top, so that's positive 54, and then our b value goes on the bottom, 15. We then think about two numbers that multiply together to make 54 and add together to make 15. That's going to be 9 and 6. We then divide by our a value, which in this case is going to be 1, and we simplify. It's already over 1, so that's simplified. We then go bottoms up. So our answer will be 1x plus 9 times 1x plus 6. That's how you factor this. Now, what does that mean? What did we just find? Well, we just found the length and the width. So we can say that the dimensions of the park are x plus 9 yards by x plus 6 yards. You can't really choose which one is the length and the width because we don't have enough information in the problem to determine which one is which, but we know that the longer side will probably be the x plus 9 and the shorter side will be the x plus 6. Cool?